Hello, thanks for having me. Today, we're going to focus on building 5-star customer experiences with voice bots and conversational AI, and leveraging the latest advances in speech recognition and understanding technologies to achieve that. As a quick intro, my name is Mehul Patel, and I'm VP of Products at Deepgram. Here's a quick agenda. We'll start off with a quick review of what are the key challenges in building conversational AI solutions, followed by latest advances in end-to-end deep learning speech recognition and understanding technologies, and how excellent customer experiences are being built using these advanced technologies. Finally, we'll review results that some of our customers have achieved already. As you know very well, building great conversational AI solutions is hard. Let's start by talking about why. First of all, complexity varies a lot depending on customer experiences you need to provide. For example, customer service chatbot with a very specific narrow range of question and answer scope and routing could be pretty simple. On the other end of the spectrum, a general purpose personal voice assistants that need to understand rich context would be highly complex. Not only are their architectures different, they require different skills to create. For the simpler solutions, existing business users can create them. On the other hand, highly complex solutions require a team of specialists that are dedicated to creating and maintaining them. As you can see on the next slide, another key dimension is that lower complexity solutions can be built using keywords or other relatively simple rules to identify and retrieve that information. Whereas more advanced solutions, like virtual assistants that can interpret questions and understand the intent, require advanced NLU or intelligence infrastructure to deliver the experiences. Voicebot development isn't plug and play. You can't simply unplug the existing text chat box and install automatic speech recognition into the conversational AI workflow and expect it to work. Texting and chatting can be looked as one-dimensional, while speech is truly multidimensional. For example, you have different tones of voice meaning different things. You have pauses in a conversation, which may or may not mean you're done speaking. Here's an example. Did he say uh-huh as meaning non-committal or as meaning affirmative? Then there are different accents or different languages with different expressions. Simple transcripts from a basic automatic speech recognition system will not pick up these differences, and as a result, may not get the words correct. And on top of that, you have to handle background noises of many different varieties. This is why customers are rejecting simple IVRs. And they're starting to really feel the frustration, especially with the simple rules-based IVRs, chatbots, and menu-driven voice bots. And they're starting to embrace more human-like bots that correctly understand the customer. So you may be wondering, what does it take to develop voice bots that will deliver delightful experiences to your customers? First, accurately identifying intent and entities depend on two key areas: recognizing the speech and recognizing the meaning. Speech recognition, or ASR, includes areas such as accurate words, timing, and confidence. Also, speech understanding, or meaning, includes areas such as diarization, or identifying speakers, detecting topics, and creating summary, just to share some of these examples. To gain deeper understanding of all of that, let's begin by reviewing speech recognition technologies, starting with the traditional models. The traditional models consist of 4 main steps, and they need to be processed in order. This model became popular way back in about 40 years ago and is based on how a person might logically break down speech processing into manageable sub-processes. First comes removal of generic background noise, stripping out certain frequencies that are present in most electronic equipment. Next, the audio is then cut into snippets of 10 to 80 milliseconds and fed into the acoustic model, which tries to identify individual sounds. In linguistics, these sounds are called phonemes. The next, in the pronunciation model, the phonemes are pieced together and most probable word is guessed, again using a probability distribution. Now you have a lattice of possible words as a function of time. Notice in both of these steps, the model generates many guesses for each sound and word. Later, it's going to discard all the candidate sounds and words that are not the highest probability. This process is inefficient, or in computer science terms, lossy, because it generates and evaluates a huge number of possible guesses that it does not use in the output. Finally, these word candidates need to be culled down to the most likely series of words that form a sentence. This is typically done with an n-gram model. The n-gram generates the probabilities of various candidate words being correct in the context of the words known to be immediately around them. An industry standard is to look at the 3 adjacent words, which is why you often hear this called a trigram model. There are some drawbacks, and here are the key ones. Fragile. It's fragile as it tweaks one layer cascade predictably into others. It doesn't build context. The closest thing it has to context is the trigram model, but it doesn't have the context for the broader conversation. When us humans think of context, it might include things said 10 minutes ago or even an hour ago. Like I'd mentioned, it's lossy, lots of data generated and discarded, and therefore it's very inefficient. And that means it costs higher. It's made even more inefficient by the fact that it is, in this system, it's designed to run the CPUs, which process data sequentially. More on this in a few minutes. In the end result is that solutions based on this technology are inadequate for some, they're adequate for some specific purpose or personal use, but don't get the job done for business applications. The limitations of these models make them difficult to build and maintain. So they are one-size-fits-all products. As a result, you get one general model for widely spoken accent and hope for the best. And this is not the future of speech, which, remember, needs to be flexible and personalized. The next slide will review hybrid models. They were developed in an effort to take advantage of machine learning within the architecture of traditional method. What does that mean? Well, they do this by incorporating machine learning in a localized way within each of the 4 steps. So in the traditional method, the acoustic, pronunciation, and language layers are usually driven by statistical models that predate machine learning techniques, such as HMMs or hidden Markov models. In the hybrid model, these older statistical models are swapped out for neural networks that handle one or more of the stages in process. Hybrid models try to build more context for the whole conversation by comparing n-gram candidates to a history of past n-gram outputs. This is known as backoff. Fundamentally, though, it's still the same process. It builds very limited context based on just a few adjacent words and stores those outcomes for reference. So what's the net impact of the hybrid model? While hybrid models can offer localized improvements over the traditional method, they do not fundamentally change the game. Hybrid models still implement the same serial 4-step process, and each step is interdependent with the step before and after it. So small adjustments to even one part of the process will cascade in unpredictable and disruptive ways into the other processes. These models are still lossy and slow. They're also labor-intensive to customize and still are typically used for one-size-fits-all general models. Aside from Deepgram, these hybrid models are the industry standard. Google, AWS, and other major providers are using, they're all using the hybrid speech model. There are two fundamental reasons why these companies haven't changed. And the reason for that is, thank you. First, the companies are doing this speech processing, they've been doing for a long time. So they've invested heavily in legacy technology that would be expensive for them to replace now. Second, most of these companies aren't focused on general purpose business use cases. Instead, they're building speech recognition first and foremost for consumer devices like Google Assistant and Amazon Alexa, where the audio is simpler, and so the older methods are good enough. If they can sell that same product to businesses, great, but that's not their main focus. That's why, as a business, you get one-size-fits-all speech solutions from them. It's not adapted to your audio and industry needs. It's not priced to scale. The product is simply not designed for business use. Deepgram's innovation is that we developed the first and only speech recognition system based on end-to-end deep learning with neural networks. A neural network is a computing system inspired by the configuration of cells in the brains of humans. In our brains, signals are received by a neuron, processed, and then passed into the other neurons for further processing. Those natural neural networks in our brains are the infrastructure that makes us so good at understanding language. So with that in mind, we use artificial neural networks end-to-end as the infrastructure for our speech solution. Our system works by feeding audio signals into the top layer of deep neural network. The system is called deep because we have many layers of neural networks that process audio in a pipeline. Each layer brings us closer to the correct result. There are no steps in our model like the traditional method. These may make it less intuitive to you when you're looking at the system diagram, but it is actually more closely resembles how language is processed in our brain. So to start, an end-to-end deep learning model is created by training the system with real label audio. That is, a sample of audio paired with human label transcripts of the speech that the audio contains. Through training, the machine learning algorithm learns how to reproduce that human label transcript by developing its own internal set of rules that reproduce the correct output as often as possible. The game changer with machine learning is that the computer does this all on its own. There is no painstaking hard coding by humans required. Simply with exposure to real audio and the correct transcripts, the system autonomously tests and iterates until it has its own set of rules for producing accurate results. So let's look under the hood. The first layer of deep neural network are convolutional neural networks, or CNNs. A CNN is a type of neural network specialized for spatial learning. What we do is we feed the CNN a visual representation of qualities of the audio. Because the CNN is a spatial learner, it looks for patterns in that visual representation. Those patterns allow the CNN to identify sounds and words with excellent accuracy. Then series of recurrent neural networks, or RNNs, and transformers. These layers are powerful sequence learners. They look at the context of the audio before and after given a word and find the best fit output based on that context. You can think of them as performing a similar function to n-gram in the traditional method. However, you'll remember that description that we talked about earlier, that the n-gram typically looks at 3 words before and after the word in question. RNN and transformers are not limited that way. They take in the context of the entire contents of the audio file. This makes the horizon for context gathering much wider. And for the speeds and cost, our system uses GPUs, or graphical processing units, rather than CPUs like in the traditional method. Because they take advantage of parallel processing, These GPUs can run end-to-end deep learning systems at very high speeds. And as a result of that, the end-to-end deep learning system is 200 times faster than the traditional method and 100 times faster than the hybrid method. An end-to-end deep learning system is also more customizable because it learns from exposure to new data. It operates at a lower cost because it's less lossy and significantly more efficient. And finally, like a human brain, the system builds context for the whole conversation to improve accuracy significantly. At this point, you may ask, what is the end result of all that? I'll let the accuracy comparison here speak for itself, as you can see from various data points. One thing I would like to highlight is that these are actual accuracy numbers on some extremely challenging real-world audio samples. Multiple speakers, background noise, lots of jargon, etc. I don't mean a little either. For example, the first example here is the International Space Station for NASA. And the last one is a phone call in the car over Bluetooth and with the windows rolled down. This is not lightweight stuff. I hope it's clear to you why our method using end-to-end deep learning has a huge advantage over the traditional and hybrid models. And this is not accidental. Our solution is the result of design choices and investments we've been making for years in order to bring the next-gen speech recognition into reality. This is what allows you to build better voice bots with technology from Deepgram. In fact, don't take my word for it. As you can see on the next slide, we have a large number of customers, and you can ask any one of them. They're using Deepgram's latest speech recognition and understanding technologies to build their solutions. It's truly inspirational for me to work with them and see them build awesome, innovative experiences for their customers. In the interest of time, I'll focus on just one of those customers, and that's Valiant AI. They have developed a proprietary conversational AI platform that integrates with existing mobile, web, call ahead, kiosk, and drive-through platforms. This includes integrating with any required on-site hardware and on-prem or cloud point-of-sale systems. And the Voicebot recommends add-on products for incremental revenues. As you have all probably felt, talking to someone through a drive-through kiosk is hard. Think about how hard is it for a machine to hear. It needs to remove all the traffic background noise, focus on one person order while ignoring the screaming kids in the car. Valiant AI partnered with Deepgram to create a speech model that can accurately hear the order in this type of environment and understand the food product names that are not common words. For example, McDouble, chalupa, and tikka masala. So Valiant AI, speed, accuracy on terminology, and removal of background noise were key to their success with us. So in summary, you can improve human-to-voice bot interactions using Deepgram's end-to-end technology, end-to-end deep learning technology. It is hugely flexible, and it's easier to optimize than the traditional or hybrid speech recognition model. And using transfer learning, new speech and or language models can be developed faster than ever before. As you can see on the next slide, it has helped our customers build great experiences based on all key factors. First, significantly increase accuracy to correctly determine intent, entity, and meaning. Second, provide very fast interactive response. Expand your solution into many languages to support your global customers. And finally, perform at a very high scale, cost-effective. Deepgram has been recognized as the leader for voice recognition solution in the software industry by many experts and developer communities, including in the latest G2 Summer Grid Report. We deliver superior results through our easy-to-use API for speech recognition understanding, and lots of clear documentation and easy-to-follow guides. You can try it all for yourself at console.deepgram.com. There, you get $150 in free credits and get started with our SDKs, guides, and quick starts. I can't wait to see what you build with it. Thank you for listening today. I'm really glad you could join us. If you have any questions, please enter them below.